Hey guys, this is your friend CoderJeet, and today I'm going to talk about the differences between a Blazor WebAssembly project and a Blazor server project. So you know already by now that WebAssembly projects are executed on the client side 100%, and they communicate with the backend if you have one, if you have any server code, through a HTTP request. And a server project, a Blazor server project, runs on the client side, but most of the code executes on the back end using SignalR. So even if you want to change something on the client side, like you want to change the layout of the form, or you want to show some new content or modify any content, the code is not executed on the client side. It goes back to the server modifies the code, and then using SignalR, it modifies the DOM, it modifies the front end, so it's a round trip every time. But let's look at the project structure and see what exactly is different between a Blazor WebAssembly and a Blazor server project. Alright, so I have divided my screen into two segments, and on the left side I've got the Blazor server project, and on the right side I've got the Blazor WebAssembly project. So one thing you will notice immediately, there is only one project in the Blazor server project, but in Blazor WebAssembly you can see that we've got multiple projects. There are actually three. So what's happening here? Why do we have three projects in Blazor WebAssembly? So let's talk about that. First thing, Blazor WebAssembly is divided into a client-side project. This project, Blazor WebAssembly.client, is obviously the client-side project, and the second part of the WebAssembly project is the Blazor server project. So this is the project which is hosted on the server. So basically what's happening here is, when the client-side code is loaded, it does need to go to a URL to request the client-side code, right? So this URL is the server, and this is a .NET Core server. This is .NET Core code. You can actually dispense with it, because when you create a new WebAssembly project in Visual Studio, it's going to ask you, do you want a .NET Core backend? And if you choose no, then this server project will not be created, and all you will get is the WebAssembly client. But then you will have to host the backend in a separate location yourself. And if you're creating an integrated application like a SaaS app, you will have a backend, and it's definitely a good idea to keep everything together. So you can create a .NET Core backend like this and put all your backend code inside the server project, and of course the client-side code goes inside the WebAssembly project. So this code talks to this code to work with the backend code. You might be working with the login and logout code with databases, whatever you're doing, it's talking to the WebAssembly code. But there is a third project too. This is the Blazor WebAssembly shared code, and this project is referenced both in WebAssembly client and WebAssembly server. And what's happening here is, this is where you keep all the classes, all the objects, all the functions, all the data that is to be common between the client and the server. So if you're going to transport any data between the client and the server, you can put the data in the shared project. Because this project is referenced in both these client and server projects, the data is going to be available to both, and it's going to make your job so much easier. And we're going to take a look at exactly how in this sample project this is dealt with in a moment. But let's go and take a look at the other differences now. So coming back to this, Blazor server of course is only a single project because everything is integrated. Without a backend, you can't run a Blazor server project because there is a server involved, right? So what Microsoft did was, they put the front end and the backend in the same project. There is no need to separate it. There's no point, and it's technically actually not possible. So it's all in there. The client-side code is in there, the backend code is in there, and the data code is in there too, because there are not multiple projects, so there is no need to have a shared data project either. Next, we've got the connected services group. Take a look here. In the server project, we've got the SignalR service, because our application, the server application, is using SignalR. SignalR is a Microsoft technology for real-time communications between the front end and the back end. Think of it like WebSockets, but implemented differently. It actually uses WebSockets in the backend, but Signalar makes it a little bit easier. So to communicate between the front end and the backend seamlessly, you won't need to write any manual code. Signalar is implemented inside of Blazor, and things just happen on the auto. You don't need to work on that. But in WebAssembly, there is no Signalar. That's because there is no backend code that is a part of the client side. So you need to send HTTP requests back to the backend. There is backend here, and if you want to communicate with the backend, they're not using Signalar because WebAssembly client projects actually free you from a backend. You can use any backend you want. You can create a WebAssembly client and then connect it to a Node.js backend. You can connect it to a PHP backend. You can connect it to a Java backend. Or you can even connect it to just public APIs and do your entire work. It's all possible. Next, let's take a look at the program.cs inside the server project. You can see there is quite a lot of content. There is the builder. Now, if you have been working on .NET Core, you know that .NET Core applications have a builder where you set up the pipeline. You set up the request pipeline. You tell ASP.NET Core exactly what you want to do with the web project. So that's what's being done here. There's a builder, you're adding Razor pages, you're adding server-side Blazor, you're adding a forecast service. It's as a singleton, this is injection. And then you are building the server, and then you're in the request pipeline, you're adding some services like you're checking if it's a development environment, then you're adding an exception handler, using an exception handler, and then you're using HTTPS redirection, you're using static files. If you remember, static files are all located in the www root folder, and this is the same for both the projects, for both client side and server side. Then you've got routing, ASP.NET ASP.NET Blazor server and client both support routing, but in the server project, the routing is a part of the core project. In the client project, the routing is a part only of the server side and not of the client side. And we will take a look at the program.cs of this project too in a moment. Then you've got a Blazor hub. This is for Signalar. In Signalar, there is a concept of hubs, and you communicate between the hub and the client. Then finally, you have map fallback to page. This is for mapping Blazor pages and your static files, and if there is no static file found, it's going to go to the 404 or give you a file not found exception that you can trap. Finally, it's running the server. Looking at the program.cs of the client project, you see that it's got very little data. It's just a root components.add app, and this is actually the identity of the element where the entire Blazor project is going to live. So theoretically, you can have a site where you've got content surrounding the Blazor app, Blazor project, and you can have the app inside of just a single div. So it's possible, but typically you would want to make a SaaS, and Blazor lets you make a software as service that is highly responsive, that's reactive, something that we call SPA, single page application. So you would want the entire page to be your Blazor app. Typically, you will just have a single HTML file which is located in www root. I do have a lesson which describes exactly how this works, so I'm not going to go in detail, but that's what app does. So it's just setting up the client side, and for the server side, you have to go to the WebAssembly server project, and you can see that this is quite similar to what you see in the Blazor server project. So the entire server project is set up, and here you've got a ASP.NET Core site that you can then tap into. You can make a HTTP request to. Talking about HTTP requests, that's a very, very important part of a Blazor project, because if you got a client side, it's going to talk to the backend only through HTTP, and Blazor tries to make it easier for you. So if you look at this sample project, when you create a new project inside of Visual Studio, it's going to set up a sample project for you. And when you look at it, inside of pages, in fetch data, you've got a component that displays the weather information. And in there is some code which is written right on the client side, which makes an HTTP call. So you can see here, forecast equals to await HTTP.get from JSON async, and this is an object being casted to weather forecast array. This is an array of weather forecast, and the weather forecast object is a part of the shared project. So this is the shared project. You can see here WebAssembly shared. This is the object that's being referred to inside of fetch data. But you will notice that this HTTP request get JSON from async is not actually specifying an entire URL. It's just an endpoint. It's just actually the name of the controller, the weather forecast controller, which is a part of WebAssembly server. So how is it doing that? Inside of program.cs in the client side, you can see there is a call to builder.services add scoped, and it is adding an HTTP client as a service. This is using dependency injection. You can inject this HTTP client instance inside of any page using this statement, inject HTTP client.http, and then you can call this directly. Now what happens here is inside of program.cs in that statement, Blazor is referring to the base address. It is setting a base address property for HTTP client, and the base address is set to host environment dot base address. So that address is used as the base address for all HTTP requests unless you specify otherwise. So what's going to happen is anytime you make a request, it's going to try and target that base address and see if the endpoint exists. Makes your things easier. Next, let's take a look at the launch settings file of the server side and the client side project. So you will notice that they are practically the same. The only difference is the inspect URI entry, inspect URI setting, which is set up to something. Actually, this is something you should never change, and it is to facilitate debugging of your client side code inside of Chrome. So when you have this set up, Visual Studio is able to figure out how to debug inside of Chrome, and your client side debugging is going to work well. And you will also notice that there is a data folder in the Blazor server project. This has the weather forecast class and the service located there. But inside of the client project, there is no data folder. The data folder is actually a part of the shared project, and it's only got a weather forecast object. It's not got a service like this one. You don't see a service here because the service code is a part of the controller. So if you look at the controller, it's got similar code. It's setting up the object, finding the data from the API that you're referring to, and the controller method is called instead of the service. In the Blazor server project, there is no controller for this because the front side code is talking to the backend code using Signalar, and all the functions are directly referable in the Blazor pages itself. So when you go to the fetch data page, you can see that all the code is directly referenced. There is just a call to the forecast service, and it's able to get the data using Signalar. So this is actually it. There are not too many differences, aren't there? Basically, you can create a server-side application or a client-side application with pretty much the same amount of coding without learning anything extra. It's just a choice of framework. It's just a choice of hosting model. But if you want to have my opinion on hosting models, I would say by default, always go for the client-side model. Don't go for the hosting model that's based on server-side, because there is frankly no reason to go for the server-side model except in very, very exceptional circumstances. And when I think about it, I can't think of even one of those. The reason is, now many people have been touting that when you run the client-side project, it's going to take longer to download, and there is a load time because it's going to download the framework. But the good point is it's not going to download the entire framework. If you look at Google Chrome tools, you can load that up. You can actually see how much data is being downloaded. Go to console and you will see that only 8.89 MBs were downloaded to make this entire app functional. Now that is not a big download. The big download is something like 40 MBs, 50 MBs. That could take a few seconds, but 8.89 MBs is not much in today's world. When you're streaming 4K videos, the advantage in performance is a lot more, because all the code is executed right on the front end, nothing goes to the back end, and also your server is left free. When you're running your code on the back end, when you're running a Blazor server project, most of the code is executed on your server. Now if you're creating an enterprise application that is used by maybe 10 or 15 or 20 users from a client, 20 clients, it's not a bad deal because you can still get away with it. But if you want to create a SaaS application that might have a few hundred or even a few thousand users, it's going to cost you big. You will have to have a more powerful, more capable server. You might even need to distribute data across many servers, and it's gonna just get more costly and more costly. What you can do instead is make a client-side app and have that 9 MBs of download. It's gonna happen only once, but when people start using the data, start using your app, all the data is gonna be already cached on their computer. They don't need to download it over and over. And once they've downloaded it a single time, it's just gonna be a very, very fast experience. There's not gonna be too many communication channels open with the backend. Only when you make an HTTP request, only then your program will talk to the backend. So it's gonna be a lot more responsive and a lot more faster. So that's my 2 cents on this. If you feel differently, if you have any opinion on this, do let me know in the comments, and wait for the next video. I will come to you with more content on programming. We're gonna talk about web programming, we're gonna talk about desktop, mobile, every sort of application, and I'm gonna make these videos on a variety of technologies, variety of topics. So please don't forget to subscribe to me and hit that like button and smash that notification button so that you know about all my videos. This is your best friend in programming, CoderJeet, signing off.